Okay, this video is the investigation on applications of normal distributions. So in the past, what have we done? We've been finding the area under a normal curve, and we can find areas under a normal curve by using the empirical rule. That's the 68, 95, 99.7% rule. If the areas are bound at places where an exact standard deviation occurs. So like if it's 1 standard deviation above the mean or 2 standard deviations above the mean. But areas that are not bounded at specific standard deviation units can be found by using a z-table, which they give you on an SOL test, or better yet, a calculator's normal function. So your calculator can help you find these values. All right, here's a big example problem that we're going to look at. This is about a corn chip factory. So a corn chip factory packs chips in bags with normally distributed weights with a mean of 12.4 ounces. So that's going to be important. Our mean, which we call mu, is 12.4, and a standard deviation of 0.15 ounces. Standard deviation was that lowercase sigma, 0.15. All right. It says on the graph at the right, label the mean and 3 standard deviations above and below the mean. So the mean in a normal curve like this is always in the middle. So I go ahead and label the middle there as 12.4, and then I want to mark 3 standard deviations above and below the mean. So while I do that, remember your third standard deviation should be out in the tail, and then just sort of space the other 2 equally. The third standard deviation in the tail, the other 2 spaced evenly. So my standard deviation is 0.15. So if I'm going to the right here, I'm going to take the 12.4 and I'm going to add 0.15. So I'd have 12.55. If I add another 0.15, it would be 12.70, and another would be 12.85. And if I go below the mean, I would be subtracting 0.15 every time. So I would have 12.25 ounces, or 12.10 ounces, or if I subtracted another 0.15, I would have 11.95 ounces. All right. It says next to label and shade the region that represents the likelihood a bag will contain between 12.1 and 12.76 ounces. So 12.1 was right here on the standard deviation mark. 12.76 is somewhere up here between 12.7, so between the second and third standard deviation. So I'm talking about all of this area right here. We know this is the majority of the graph, so if we're trying to find the area or the probability, this should be a number that's relatively close to 1. It says, use your calculator's CDF function, your normal CDF function, to find the area shaded. Let me pull up a calculator. Okay, so on the TI calculator, I'm going to go second distribution, and the second one down there is a normal CDF. To get to this area, if you have a Casio, you go into the stat menu, and then you hit F5 for distribution, right? So on your Casio, you hit in stat, you're going to hit F5 for distribution, and then you're going to hit F1 for normal, and then you're going to hit F2 for norm CDF, and then F2 for variable, and this is going to look the same now from then on out. Your lower value is your left side. So my left side right here was 12.1. That was my lower of my 2 values. Your upper is your right value. My right value up here was 12.76, or my higher of my 2 numbers. Then I'm going to put in my mu and my sigma. Be sure you're putting the correct thing in each one. They're in the opposite order if you're using a Casio. My mu was up here, that was 12.4. Sigma, or standard deviation, was 0.15. Then it says paste. I hit enter, It might say execute on, depending which calculator you have. You just hit enter again and it tells you. So this is the normal CDF. This is the value, or the total area that's in here was 0.9690. If it asks for the area or the probability, I would give this number. I think it's a good idea when I'm done to make sure it made sense. I said this should be a lot of the area, so it should be pretty close to 1, and that one was. All right, in the next question it asks, if a convenience store ordered 375 bags of chips, how many bags would you expect to contain between 12.1 and 12.76 ounces? So we know that the probability that you're between 12.1 and 12.76 ounces is 0.9690. So we have to find that portion of the 375 bags of chips that were sold in the store. So I'm just going to work that out. So I can just use the answer button on my calculator to multiply by 375, and that gives me 363.3946. I usually write down this answer to 4 decimal places and then think, is this something I can really have a portion of? Can I have 363.3 bags of chips? No, I really should round to a whole number, so I'll make that go down to 363 bags. Okay. Okay, moving down, it says, number 5, shade the region that indicates the bags that contain less than 12.64 ounces. So 12.64 ounces was going to be somewhere over here. If it's anything less than that, it's this whole area over here to the left. So now I'm going to use my calculator's normal CDF function again. So I'll go into second distribution, normal CDF. My lower for this one would be all the way over here on the left. Well, where am I going on the left? I'm going all the way to negative infinity, but I can't type that in. So I suffice by just typing a negative and a whole bunch of 9s to make the biggest negative number possible I can put in there. It's not going to really matter if you put in, 1 or 2 or 3. It'll be fine. Your upper value is 12.4 because that was the right side. My mean and my sigma were still the same. So this gives me 0.5. Okay, now my brain's saying 0.5, that doesn't seem right. 0.5 should be from here to the left. So I'm thinking maybe I typed this in wrong. Did I type in my upper as 12.64 like I was supposed to? I don't think I did. Let's go back and check. Second distribution. There it is. My lower was negative a whole bunch of 9s. That's fine. My upper, 12.64. There we go. That's what I did wrong. I don't know why my mean and my standard deviation just got lost. My mean was 12.4 and my sigma was 0.15. And then I hit paste. And there we go. Looking much better. All right. So this area is 0.9452. All right. What percentage of bags? Well, this was a decimal, so I just need to move the decimal place over to 94.52% of the chips. Okay, so now number 7 says you're really hungry and you want a bag that's in the 90th percentile. 90th percentile means that 90% of the bags weigh less than you. So on the graph, where is that going to be? The 90th percentile is going to be way up here. Do I know what this value is? No, I don't know how much that bag weighs. That's what I'm trying to do, is determine the bag weight associated with the 90th percentile. The 90th percentile means this area right here has to be 0.9. So I know it should be somewhere around this amount because that was the 94th percentile, but I got to find out exactly where it is. So in my calculator, in the same way I got second distribution, where my normal CDF was, if I go down one more, that's the inverse normal. So normally we put in the values that were down here on the x-axis, the lower and the upper, and it told us the area, but we're going to do the opposite. We're going to input the area, and we want it to tell us what the x value is. So that's an inverse. Inverse normal, the area is 0.9. The mean, this was the 12.4. The standard deviation was 0.15, and it tells me I'm at 12 12.592. And again, I thought it should be somewhere close to this 12.64 we had in the previous problem, which it is. So in this one, sometimes we have to round, but can we have a bag that weighs 12.59 ounces? Sure we can. So I'm going to go ahead and list those all out. The weight was in ounces, so I'm going to put units. There we go. Okay, on to the back. We have a herd of 972 adult unicorns. The lengths of the horns are normally distributed with a mean of 10.1, so that's going to be my middle right there, 10.1 centimeters, and a standard deviation of 1.04. So that's my sigma. All right, so on the graph, label the mean and 3 standard deviations above and below the mean. So you can pause the video while you label that. Okay, go ahead and check yours and be sure they match up with mine. I will confess I did come over here and type them into a calculator because it was just faster. And be sure that when you're drawing them that this third standard deviation is out here in the tail. All right, so I've done the graph. Now it says on the graph at the right, shade the region that represents the probability of a unicorn's horn being longer than 9 centimeters. So let's look at where I am here. My mean was in the middle here at 10.1. 9 centimeters would be somewhere around here if I'm looking at my scale that I had up on the top graph. So if I'm going to be longer, that means everything over here to the right. Again, I want to think about what this should this be. This is a large area, maybe like a 0.9 or a 0.8, something close to 1. It should definitely be more than 1. All right, so let's go into our calculator. We're going to do a second distribution again. Normal CDF. My lower bound for this one is going to be the left side. The left side is 9. My upper is going to be the right side. Well, my right side over here goes up to infinity. So I usually am just going to type a bunch of 9s. Doesn't matter exactly how many I type. My mean was 10.1. And my standard deviation was the 1.04. So my area I get is 0.85, and that seems reasonable. I said I thought it might be about a 0.8 or a 0.9. 0.8549. And it asked for the area, so that's exactly the number I want to keep. My area always has to be a number between 0 and 1. All right, so what is the probability? Well, the probability is the exact same thing as the area. The number between 0 and 1. And then when they ask in the next one how many unicorns we have, well, we had our probability or our percent of 0.8549, and then we have to take into account how big was the herd. Well, up here in the problem, they told us there were 972 unicorns. So I'm going to take my 0.8 number and I'm going to multiply it by 972 to give me 830. Whoops, start writing. There we go. 830.9648, which I can't have a decimal proportion of a unicorn. You could probably make an argument for whether it should be 830 or 831. I think if this were on an SOL test, they would probably take either one. Unicorns. I'll round up because it's the closer one. Okay. All right, let me scroll down. On this one, they ask us to shade the region that represents the probability of a unicorn's horn being longer than 10.5. So longer than 10.5 means up here on the right side of 10.5, or less than 9.5. 9.5 would be somewhere over here, and that would be this green area. So what's the probability that I'm either one of those? Well, I have two choices for this one. I can either find this green area and then find this blue area, and then I could add those two areas together, or I could find the white space in between, knowing the total area was 1, and I could do 1 minus the white space. I should get the same answer for both. I think it's easier to just do one area. So I'm going to calculate the area of that white space right there. So I do second distribution. I have a normal, so I go to normal CDF. My lower would be the 9.5. My upper would be the 10.5. My mean and my standard deviation are still the same. I go down to paste, and I get the area of the little white space in there is 0.3677. Okay, so I have 1 minus that answer. 1 minus the answer. And that gives me 0.6322 as my area. Again, that's the same area as I would have gotten if I had found the green and the blue and added them together. So then it asks what percent of unicorns follow this requirement of being greater than 10.5 or less than 9.5. So that would just move the decimal place over 2 places, 63.22%. And then they ask us how many unicorns, which would mean I would just multiply my probability times the size of the herd, which was 972, I believe. And that gives me 614.5537. Again, I'm going to write the number down to 4 decimal places, but I can't have a half a unicorn. So I could argue here to have 615 or 614. I would be okay with either one. We really, I don't know if you've noticed, but one of the things that's a little strange when we do this in Algebra 2 is we say longer than or less than. We really kind of skirt the issue of what about equal to? Do we care if they equal? That's not in our realm of Algebra 2, so that's why we can be a little loose with how we're accepting more than one answer. Okay, in the last one, it says in order for a unicorn to be in the parade, her horn must be in the 75th percentile. That means that 75% of the unicorns have to have a horn that's shorter than hers. So this area is now 0.75. We want to work backwards to figure out what x is the length of the horn. So remember on our calculator, that was the opposite of what we usually do. So when we go to second distribution, it is an inverse normal. So the area is 0.75. The mean was 10.1. The standard deviation was 1.04. Sorry, my pen died on me here. So that gives me x of 10.8014. Is that an acceptable answer? Can something be 10.8 centimeters? Sure. So I'm going to go ahead and list it out to the 4 places after the decimal. Okay, just be sure you're paying attention on your calculator of whether you know the area and you're doing an inverse, or whether you're finding the area, in which case you're doing the CDF. We didn't go into it, but if you did the normal PDF, the stuff it asks you for up here is not what we're used to. So we don't use that one. All right, let us know if you have any questions.